Okay, this is Leetcode 200. Just making sure I can see everything. Okay, yeah, this is Leetcode 200, and this is a medium level question. And the question is count the number of islands. So you're given a matrix or grid, and it's going to be n by n. So it's not going to be necessarily a square matrix. It could be you could have more rows and columns, or more columns than rows, and whatever. So the idea is there's water outside of this matrix, and there's going to be binary values. So 1 would be equal to land, and then 0 would be equal to water. And then you assume that everything outside, everything surrounding the grid is water. So in this case, what we're trying to do is count the number of islands, and you don't count diagonally. So if you just had like 1, 0, 0, 1, and then everything outside of it is water, you would have 1 island and 2 islands. So this would be, you would return 2, and then if you had something like this, then you would return 1 because you have 1 island because they connect. So that is the idea. And this was pretty easy. The solution was kind of apparent to me, and then I was figuring out different ways that I could do it. So the way that I originally did it and how I'm going to do it today is modifying our given array. So we'll just call this grid. And I just circled that in green to denote that that's our island. So that would just return 1. Right, because 1 represents the number of islands in our grid. Yeah, so I immediately thought that this was like a DFS kind of BFS approach. What I wanted to do was iterate through the grid, the matrix, the number of rows and columns, so that you could get each individual cell. So in Python, let's just define our function signature first. So define count islands, and then we take in a grid, and then and then we could comment like returns int representing the count. Yeah, so we need to store a count somewhere, right? So we can just do ISL count, and count, we initialize that to 0, and do we initialize anything else? So yeah, so in an in-place solution, like I said, we're modifying the grid. We don't have to store anything else. If they say you have to, or you can't modify the grid, then you can either copy this this grid into like another variable, but you'd have to do a shallow copy, I believe. In Python, you could just do like cgrid, which is copy grid, is equal to grid, and the syntax to make that shallow copy is that. So, but we're not going to do that. Yeah, so what we're going to do is use like a DFS approach to branch out and use that to mark the cell as visited whenever we find an island. So here's how we'll do it. So we'll set row, and then rows, and calls is equal to the length of the grid. So this is our rows. And then the calls would be the length of the first element in the grid. Right? And then we can iterate through that to get our cells. So we'll go for R in range of rows, for C in range of calls. So what we're doing here, we're trying to go through each cell and see if we find a land value. So if grid R C is equal to Yeah, it's an integer value. So if it's equal to 1, then what do we want to do? We found land, so we need to increment the count value. So we'll do ISO count plus equals 1. So you can imagine here we find this value at index 0, 0. So we're currently at here. And then we increment ISO count is equal to 1 right now in this iteration. And then we're going to call our helper function. I just called it DFS. Yeah, we'll just call it DFS. And we'll go to the grid, that row that we're at, the column that we're at. And that's it. And then at the end, we're going to iterate out. And then we're just going to return ISO count. Right? So yeah, let's go through our helper function now. Oh, yeah. Here. Okay. So we'll define here DFS, call it DFS helper or whatever. Grid, RC. And here what we're trying to do is mark our visited node so that we don't visit it again. Because if we, in this example, if we go to the next one, we don't want to count it as an island again, because from here we should just branch out and then see that we visited all these nodes surrounded by the green border, and then say that our count is at 1. So DFS grid RC, we need to check if it's a valid area first, which it should be. If we call it here, but we're going to call it recursively, so we do need to check it. So let's do, if not grid, or R is less than 0, or C is less than 0, and there's going to be a lot of checks. Or R is less than, or greater than, or equal to the length of grid. And these are like common checks. So if you haven't seen this before, like when you're, especially when you're going through a matrix and like using DFS, you're going to do these checks very often. So you're just making sure that it's within the bounds of our grid, where C is less than or equal to grid, that first element, like that. So if it's not in the bounds, then we don't want to do anything, right? We'll just return. And then otherwise, so if we get into this else statement, that means we are within the bounds. And we have already seen, because we're only calling this function when the value at RC is 1. So that means there's a land value here. So what we want to do is we don't want to visit again when we're at the second item, because then if we're here, we're going to count that again as a land. And then we're just going to keep, for each of these ones, we're going to keep adding a 1. So we don't want to set our island equal to 7, right? There's 7 ones. We want to make sure that each thing is only called, each one is only added once, each cell. So what we do is we can set that item at RC. So we're modifying our grid here. So grid of RC is equal to 0. So now we're saying that this is a water value. We're saying instead of 1, now it is now 0. And then here, we're going to recursively call this function with DFS, and we're going to do R plus 1, R minus 1 to save like space on the whiteboard. I'm just going to do plus minus 1, and it should be grid first. Yeah, so it's DFS grid R plus minus 1, and then C. Right, so there should be 2 lines here, right? Grid R plus 1C, grid R minus 1C. And we're not going diagonal, so we'll call it again, grid. So we went to R plus 1, C plus 1. We just do each of them individually. C plus minus 1. So these should be 4 lines total, recursively. So what happens here is we go here, we set this one to 0. I'm just going to cross it out. and then we'll go recursively. We'll check the bottom one, the top one. Top one's out of bounds, so we don't do anything there. Bottom one is within bounds and is 1. Right? So we set that to 0. And then we go to the right. Top one's out of bounds. Left one is now out of bounds. Or not out of bounds, but left one is 0. So we would set that to 0 as well. Is that grid? Yeah, so actually that might... Here, it's going to go to our else, and it's going to DFS to the left as well. So we might actually revisit nodes even though they're already 0. I guess just to make sure, what we could do is add another check here. We could do like if grid of RC. There shouldn't be a comma there. Equals 0. We can just add that in there. Then we don't want to check it, right? So yeah, we'll go here, go to the right. Or we can do that first. And then we recurse to the right. No, 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 no. So now every value in this grid is now 0. And then we break out of this DFS loop here. And then we'll still continue iterating through each of these elements. They're not equal to 1 anymore. Right? Yeah, the grid in RC is no longer equal to 1. After the first iteration, everything is changed to a 0. So it's going to continue looping, and then at the end, we're going to return island count, which happens to be just 1 in this example. But if you go through other examples, you'll see that it's the same thing. So like for our simple example that we showed before, like 0, 1, or 1, 0, 0, 1, what's going to happen here, right? It's going to go through range or rows and calls. It's going to find island here. It's going to count 1. And then it's going to set this to 0. It's going to iterate next. It's a 0, 0. Count here. Another 1. 1 plus 1 is 2. Set that to 0. And then this would return 2 for island count. So that's kind of how the program would run and how you can visualize it. So the helper function does most of the work, and here you're just checking. What you're doing is just incrementing the count and checking if that value is equal to 1. So another way to do this, instead of updating this as well, is to keep like a visited set that you would initialize in this example here. And when you DFS into something that equals 1, you could add it to a visited set. You could add the row and column tuple to a visited set, and then if that cell was already visited, you wouldn't count it again. So that's another way to do it. Similar runtime, but at added space, right? Because you would have to store those row and columns into a set. But in that case, you wouldn't be modifying the input array, which is what they might want. So that's another working solution. You just have to modify just a little bit of this code. Obviously, add like a visited set here, here, and here, and then check here. If RC is in visited set, then just return. And here as well, if grid is equal to 1, you do this. Or you check before, like if RC is in visited, then just continue or pass. In this case, it would be continue. So yeah, hope that helps.